All right, let's keep going. These are gonna get more complicated, so I don't think I have space right next to each one. So I copied this, I pulled this out and I copied it to a new page. So let's just work through them. So 23, this one, 25 sine x minus 43x to the 10th. Point of this is just that you're just going to differentiate each one separately and put the minus sign in between, right? So that's going to be 25 cosine x. And I'm going to bring the 10 down in front, get 430 x to the 9th. Okay, so that's that one. The derivative of x sine x. So sadly, we cannot just differentiating by, differentiating x and differentiating sine x. The answer is not, it's not 1 times cosine x. It's not that. It's actually, there's this product rule, right, which says you have to do the first times the derivative of the second plus the second times the derivative of the first. So this is actually the first. I mean, one way you could write this, I like this d over dx notation because it kind of hints to you what you need to do. You're basically doing that first times the derivative of the second plus derivative of the first times the second. And so that's x, derivative of sine is cosine, plus the derivative of x is just 1 times, and then you don't do anything with sine. So that's the answer, x cosine x plus sine x. Okay. Oops. 25, very similar. It's the first times the derivative of the second. Derivative of cosine is minus sine, so I'll put the negative sign here. So it's negative t to the 5th sine t plus the derivative of the first, 5t to the 4th times cosine of t. Okay, so that's that one. 26, again, very similar. I'm just going to blitz through these. I guess this is a little more complicated because of the 7x inside the sine function. So it's the first x cubed minus 2x times the derivative of sine of 7x. Remember, the idea is it pops the 7 out in front. Sine becomes cosine. So it's 7 cosine 7x plus the derivative of the first. Derivative of x cubed minus 2x is 3x squared minus 2 times, and then we don't do anything to the sine of 7x. Okay, so there you go. That's that one. And 27 was root x times e to the x. Well, again, that's, I could rewrite that as x to the 1/2 times e to the x, which is, again, we're going to do the first times the derivative of the second. E to the x doesn't change, though, plus the derivative of the first, 1/2 x to the minus 1/2 times the second, which is, again, just e to the x. So you could do something like factor the e to the x out, or you could rewrite these in terms of square roots. That's root x plus 1 over 2 root x times e to the x, if you like. It's not that big a deal. You can leave it whichever form you want, but yeah. Okay, so that's 27. Let's keep going. 28, sine u over u. Okay, so that's right. The derivative with respect to u, sine u over u. Well, there is this thing called the quotient rule, so I'll do it 2 different ways. I'll do it with the quotient rule, which is this thing where it's like, I don't know, there's this, if you call this the high function and this the low function, then it's low d high minus high d low over low low. Actually, my teacher said called it high and ho, so it was ho d high minus high d ho over ho ho. But if you do that here, you get the bottom. It's basically bottom times the derivative of the top, u times cosine u minus the top times the derivative of the bottom. So that's just sine u times 1 because the bottom is u over u squared. Which if you like, you could break this up as like u cosine u over u squared minus sine u over u squared. And then these two, a u here cancels that squared there. And so it's cosine u over u. Just showing this because this is what the second way we do it is going to look like. Cosine u over u minus sine of u over u squared. All right, the other way to do this is, since the bottom is pretty simple, you could just write it. You could always rewrite things this way. Like instead of writing divide by u, I could write times u to the minus 1 power. Right, that's the same expression. And so if we do that, now we can differentiate this using the product rule. So it's the first times the derivative of the second, remember, which is minus 1 over u squared, u to the minus 1, it's minus u to the minus 2, which is minus 1 over u squared, plus the derivative of the first, cosine u, times the second, which is 1 over u. And if you notice, these are actually the same. There's cosine u over u, there's cosine u over u, there's minus sine u over u squared, that's minus sine u over u squared. So either way, it gives you actually the same answer. Okay, a few more. 29, x plus 3 over x plus 5. Okay, again, you can use the quotient rule. Yeah, you might as well. There's a few slick things you can do here, but you might as well just use the quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of the top is 1, derivative of the bottom is 1 over the bottom squared. So that's x plus 5 minus x plus 3. So that's x minus x cancels, and then we do 5 minus 3 is just 2. So that's 2 over x plus 5 quantity squared. Yeah. I was going to say the super slick way to do this, if you really wanted to be, I wouldn't expect, these are things you get just from lots of experience, is that you can actually rewrite the numerator as x plus 5 minus 2 over x plus 5. And then you can break it up as x plus 5 over x plus 5 minus 2 over x plus 5, which is 1 minus 2 over x plus 5. It's kind of a nice way to rewrite the function x plus 3 over x plus 5. Shows you a little bit maybe a little more what's going on with the function. And then when you differentiate this thing, well, it really does become that, because the 1 goes away. The 1 over x plus 5 becomes minus 1 over x plus 5 squared. So there's a next picks up a minus when you differentiate this, which crosses out that minus, and it becomes squared on the bottom, and the 2 just sits there. So, all right, that's another way to do it. Okay, keep just a few more. Right, so I had the derivative of tan x was secant squared x, but if we actually use the quotient rule on it, we can actually see it. If we rewrite sine x as tan x is sine x over cosine x, we can actually do this. So 30. The derivative of tan x, tangent x, is the derivative of, it says tangent is almost by definition sine over cosine. So again, quotient rule, that's the bottom times the derivative of the top. The derivative of the top is, I'm just going to be a little more explicit here, times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So the top becomes cosine x times cosine x, right? Because the derivative of sine is cosine. The other part of the top becomes minus sine x times the derivative of cosine x, but that's negative sine x. Still all over cosine x squared. But if you simplify this, this becomes cosine of x times cosine of x, cos squared of x. And then we have a minus here and a minus here that cancels. So we get a plus sine squared x all over cosine squared x. And here's the thing, that numerator is 1. So that is actually 1 over cosine squared x, which is 1 over cosine is secant. So that's secant squared of x. Another thing you could do is you could also break this up into two fractions, cosine squared over cosine squared plus sine squared over cosine squared. In that case, you would get 1 plus sine over cosine is tangent. So you could also write this down as the derivative of tangent, 1 plus tangent squared. But these two things are equal. These are the same. There's another nice trig identity, right? The trig identity we used was that sine squared plus cosine squared is 1. But these are also, this is another trig identity. And you can sort of see, you can actually see why it's true here, because algebraically they work out to be the same thing. All right, I might as well, just for completeness sake, do this last one. There's something about simplifying the answer. So it looks kind of, you know, blah, but maybe the answer simplifies. So 31. The derivative of root x over x plus 1. So that's the derivative of x to the 1/2, x plus 1. Use the quotient rule, top times the derivative of the bottom, 1/2 x to the negative 1/2, minus, sorry, the bottom times the derivative of the top, minus the top times the derivative of the bottom. Derivative of the bottom is just 1 over the bottom squared. All right, and why am I claiming that I can do something interesting here? Well. Okay. This is, I mean, you could leave it like that, but there's something a little bit interesting here. Like, we have 1/2 times x plus 1 times 1 over root x. That's what that x to the minus 1/2 is, right? Minus root x all over x plus 1 quantity squared. Now, here's the thing. Here's where I want to be a little goofy, like a little interesting. Root x, I can rewrite this as x over root x. That's actually true, right? If you take like 4 divided by the square root of 4, you get the square root of 4. If I take 9 divided by the square root of 9, so 9 divided by 3, I get 3, which is the square root of 9. So you can see if that's true. And then I can actually factor a 1 over root x. I don't know that it's that fascinating, but if I rewrite that, I can factor 1 over root x out of the numerator. So there's a 1 over root x times a 1/2 times x plus 1, which is 1/2 x plus 1/2. And then when I factor out the 1, if I factor out the 1 over root x, I just get an x. Right, I've sort of factored out, I factored out this 1 over root x right here. And I'm left with an x, the x on top, which goes there. And then that's all over x plus 1 quantity squared. And okay, again, I mean, I just like to see how, I like the exercise of seeing how far I can simplify something. May not simplify that much, but you get the 1/2 x plus 1/2. So the 1/2 stays, 1/2 x minus x is actually minus 1/2 x all over x plus 1 squared. So the 1/2 factors out. So you're going to get something like the following, which maybe you don't even think of as being better. I think you get that 1 minus x over 2 root x times x plus 1 quantities squared. So, I mean, at least that's something. I mean, this to me, this expression right here is pretty ugly to me. Yeah, I mean, right. I suppose the other thing you could do, just to belabor this even more, is you could also have done the thing where you avoid the quotient rule, where you say this is the derivative of x to the 1/2 times x plus 1 to the minus 1 power. And then that is the first times the derivative of the second times minus x plus 1 to the minus 2 plus the derivative of the first times the second. You should basically get about the same thing as before. But I mean, you could write this as minus root x over x plus 1 quantity squared plus 1 over 2 root x times x plus 1, something like that, which I claim is the same thing. And again, this is all sort of a little bit, it's all kind of unpleasant no matter how you look at it. So, but you know, sometimes you need to simplify derivatives. All right, that's good enough. I'm going to stop there and do one more video about chain rule derivatives.